Hi everyone, so this video is the start of a string of videos on solving simultaneous equations. I will run through lots of example questions as well as how the topic could be relevant outside the classroom. We will first start off with a quick recap video on what you need to know before tackling any problems, but if you are completely new to simultaneous equations or have forgotten more than you know, then there's some useful links in the description so you can gain an in-depth understanding before watching these videos. So let's make a start. First thing we need to remind ourselves is, what is a simultaneous equation? So I'll just write this here. So what is a simultaneous equation? Well, let's say we had some equations such as 3x plus y is equal to 30. Now this equation has two unknown variables. We've got x and y, which means it can have an infinite amount of solutions. So for example, we could have x is equal to 1 and y is equal to 27, or x is equal to 2 and y is equal to 24, or even x is equal to 100 and y is equal to minus 270. But we could literally choose any value for x and then find the value of y that would make this equation true. Now the only way we could get an answer that is actually useful is if we had another equation that we can use alongside it. So for example, if we had 3x plus y is equal to 30 and 4x plus 2y is equal to 20, then the unknown variables of x and y are the same for both equations, which in fact helps us to solve the unknown values. As without a second equation, we would not be able to solve the values, as we know that we'd have infinitely many solutions. Now the reason why a second equation will help us is that independently there will be an unlimited amount of solutions for each question, but as a system of two equations there will eventually be a set of solutions that work for both equations simultaneously. So for example, if we graph two equations here, so we have 3x plus y is equal to 30, and we also have 4x plus 2y is equal to 20, then if there exists a solution, then we should see that there is a point where the two lines intercept each other. So here we can see straight away that the lines aren't parallel, as the distance from here to here is greater than the distance from here to here. So we know that they will eventually meet each other. Now if I move further down, we can see the points where the two lines intercept. And I'll zoom out a little bit as well. So here we can see that the two lines are crossing, which is where they intercept, which means the solution which satisfies both equations are the coordinates of where they intercept. So we've got x is equal to 20 and y is equal to minus 30. So let's just jump onto the whiteboard and check that for our equations. So we have 3x plus y is equal to 30, and if we were to substitute x as 20 and y as minus 30, we'd have 30 times 20 plus minus 30 is equal to, well, 3 times 20 is 60, plus minus 30 is just minus 30, and 60 minus 30 is 30. So the solution works for this equation. And for the second equation, if we have 4 times 20, which is 80, and 2 times minus 30, which is minus 60, and 80 minus 60 equals 20. And I've just realised that I've written 2 here, that should have been a 20. So we know that the solutions also work for this equation. So you might be able to follow through what I've just done there, but you might not have any clue of what the point of doing that was. So let's just make another heading here where I'll say, so what's the point of simultaneous equations? So what's the point of simultaneous equations? Well, it turns out if something's got anything to do with having to get to a certain location, then it will have some relevance towards simultaneous equations. So this could be things like air traffic controllers, trajectories of an object going through the air, or even when deciding or comparing things like car insurance or a certain type of loan. But I'll be showing you an examples in the relevance video on how you could use it outside the classroom. So I guess the main thing we need to ask ourselves is, how do we solve a simultaneous equation? So how do we solve a simultaneous equation? Well, we are actually spoilt for choice on the methods we could use to solve simultaneous equations, but the one we're going to focus on are substitution. So substitution and elimination. So elimination. Okay, so recall that substitution is where we have something in the form of x is equal to, I don't know, something like p, where p represents a value, and then we want to replace the value inside an expression or equation with the value for the variable. So an example would be if we had something like 3x plus 2, and let's say x was equal to 4, then we would have 3 times 4 plus 2, which is equal to 14. So that's where we've substituted x is equal to 4 into 3x plus 2. Now substitution for simultaneous equations is no different, apart from we often have to get the equation into the form of x is equal to. So let's just go through the steps for substitution. So step 1 is where we need to rearrange one of the simultaneous equations so that you obtain an equation for x, which is in the form of x is equal to some stuff. But ensure you choose the equation that's easiest to rearrange. So we'll put rearrange with the easiest equation to get x is equal to some stuff that's just in terms of y and some constants. You could obviously start off with y if you wanted to. So step 2, we need to substitute x into the other equation that you did not choose in step 1, and then simplify this to obtain the value for y. So if you think about it, if we have two sets of equations, and we rearrange one equation to x, so that is x is equal to some stuff that's just in terms of y and constants, then when we substitute x into the other equation, the whole thing is going to be in terms of y's and some constants. So that way we can simplify to end up with y is equal to some constant. So for step 2 we'll put substitute x, so sub x into the other equation, and then simplify. To get y equals some value. So at this point we should have an actual value for y, which means in step 3 we could then substitute the value for y into the equation of x that we found earlier. So then we sub y into equation for x to give value for x. And then at this point we should have a value for x and a value for y, so then we can simply sub our solution of x and y into both equations. And then what this will do is that it will make sure our solution that we found are valid for both equations, which would mean that our answer is correct. So now with this method it can be very simple and sometimes you can complete this quite easily. The only problem is that if you make a mistake when rearranging, so if you have something that's quite complex and you're having to rearrange for x, then it's quite easy to make a mistake. So now the other method we have is elimination. So recall that elimination is what happens when an unknown variable is reduced to 0 due to either subtracting or adding one of the equations to the other. So for example, say if we have something like 3x plus y is equal to 11, and we also have 2x plus y is equal to 8, then what we're able to do is just draw a line underneath, and then we choose one of the variables. So let's choose y in this case, because both y variables are just one y. So what we have to say to ourselves is, how do we eliminate y? Well, we can eliminate y by subtracting the second equation from the first one. So we get 3x minus 2x is equal to x, and y minus y is equal to 0. So that's y eliminated. which is equal to 11 minus 8, which is 3. Then this then gives us the solution that x is equal to 3. Then we can then target the x variables and get the solution for y. So the steps for the elimination method are, we want to identify the unknown variable that we want to choose first. So basically, choose a variable. Then step 2 is, if needed, we need to multiply or divide one of the equations by a factor so that the unknowns have a common coefficient. And what this means is, if we had something like 3x plus 2y is equal to 16, and then 2x plus 1y is equal to 4, then if we wanted to eliminate y, the easiest thing to do would be to multiply this bottom equation by 2, so that we would end up with 4x plus 2y is equal to 8. Then we would use a second equation in order to eliminate y. So we'd obviously have 3x minus 4x, which is minus x, 2y minus 2y is 0, and then 16 minus 8 equals 8, which would mean that x is equal to minus 8. So that's what we mean by step 2. So in step 2 we can write multiply or divide one of the equations by a factor so the unknowns have a common coefficient. And then step 3 is either add or subtract the equations together to eliminate the chosen value. So you've used multiplication or division to make one of the sets of variables the same for both equations, and now you use add or subtract to eliminate that variable. So we can simply put add or subtract equations to eliminate chosen variable. Now step 4 is to simplify what you have left. So simplify what's left. And then make the remaining variables the subject. So you have x is equal to something or y is equal to something. So e.g. x is equal to. Then step 5 is to repeat the process to obtain the value for y, and then substitute the solution into both original equations to check the answer. So we'll put repeat the process and check. Now the elimination method is actually quite useful sometimes, as it can deal with more complex systems without the amount of risk of making a mistake that rearranging might give. But now the steps for these two methods are how we're going to tackle the problems in the example videos, where you can see the two methods in action. But that's it for this recap video, but make sure you check out the other videos so that you can strengthen your understanding of this topic.